Group 13 elements. This is your 11th class chemistry, and here Lakshma Reddy sir. Right? Assignment 4. The hybridization of boron in borax is. In borax, there will be 4 boron atoms. In that, 2 boron atoms will have 4 bonds, and 2 boron atoms will have 3 bonds. The 3 bonds containing is sp2 hybridized, 4 bonds containing is sp3 hybridized. This structure I have explained in last topic. You can check that one. It will be oxygen, it will be oxygen, 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 oxygen. So all these will have one OH group. This is sp3 and this is sp2. sp3 and this is sp2. So 2 borons sp2 and 2 borons sp3. That is the right one. Which reacts with acid as well as alkalis, that is aluminium, and releases hydrogen gas. With dilute HCl, dilute H2SO4, hydrogen gas is released. Among third year group elements, boron has highest melting point. True. Boron has giant polymeric structure. Exactly. The statements regarding boron and aluminium are: boron is a bad conductor of heat and electricity. Okay. Aluminium hydrides are stable. Maximum covalence of boron is 4. This is right. This is right. Aluminum hydrides are stable. Aluminum hydrides are not stable. They will be participating in bonds. The correct order of melting points of third year group elements is, it is memory based, you can remember, and generally that type of questions won't come. This is just for practice now, so you can see. The third year group element that does not displace hydrogen from hydrochloric acid is, that credit goes to Mr. Boron. In BF3, the oxidation number of boron is +3, right? Boron can form a stable B+3 cation. This is wrong. Okay, now this cannot form a stable B+3 cation. Oxidation state is different and cation formation is different. This is a covalent compound. Here fluorine electronegativity is more, so negative. So this is getting positive, that's all. But doesn't mean that it can form cation. B+3 cation is impossible. Okay, so A is true or is false. Eighth one. The maximum number of atoms present in the same plane of diborane molecule. Diborane will be like this. B, same plane, same plane, same plane, same plane. So these three will be in the same plane. So 6 atoms will be there. The statements regarding diborane are: diborane contains 2 centered 3 electron bonds. No. BH bond is formed by sp3s overlapping, right? It contains 2 coplanar BH2 groups, right? So 2 and 3 are correct. Diborane does not liberate hydrogen gas with KOH. Remaining all it will get released, but these all reactions are not there now. NCERT don't search. Diborane does not liberate hydrogen gas with, sorry. KOH it will liberate, sorry. NH3 at 120 degrees Celsius, it forms actually B2H6.2 ammonia. Okay, but when you are heating, hydrogen gas will come out here. So here no hydrogen is coming, option 3. Sorry. 2x plus LiH B2H6 plus Y, X and Y are. You can see now. What is there easily? Here X and Y, which can reduce lithium, what you say, X into B2H6. That must be boron compound. Generally BCl2 type of compounds will be there, or BBr3 or BF3, these kind of compounds. And when you are taking here BF3, you are getting here LiF. 2 moles of hydrogen gas liberated by the reaction of the same weight of aluminium separated with dilute HCl and dilute NaOH. Okay. Al plus 6HCl gives rise to AlCl3 plus 3H2. I just wanted to show you that 2 moles of aluminum gives 3 moles of hydrogen with acid. Same 2 moles of aluminium with sodium hydroxide dilute forms to NaAlO2 plus 3H2. What you need to notice here is 2 moles, 2 moles, 3H2, 3H2. So when 2 moles of hydrogen gas you are getting means 1 mole here, 1 mole here, means these aluminiums, they must be in the same ratio. Okay, so it must be 1. Interesting question. Aluminium impure plus dilute HNO3, X plus NH4NO3 plus H2O. Here what happens? What is the product? The hybridization in the central atom of the anion of X is, okay, now aluminium when reacts with dilute HNO3, whatever the compound is formed, he is asking the anion of that. In that anion of what is the hybridization of the central atom? Aluminium when reacts with NH4NO3 and dilute HNO3, it is going to form. One second, let me check this equation. Aluminium with dilute HNO3, because with concentrated HNO3 it becomes passive. With dilute HNO3 it should release. Aluminium nitrate and ammonium nitrate. Ammonium nitrate is mentioned here. This is aluminium nitrate. He is asking the anion part. Anion part is NO3 minus. NO3 minus hybridization is sp2. Good question. When you are thinking means that definitely good question, right? And when you don't know, learn it. That's all. Don't try to give something which may be right. It may not be right answer. Okay, so accept it. There is no rule that you should know every point. The statements regarding alums are: potash alum is used in the modern, right? Lithium plus cannot form alums, right? And ferric alum does not consist of ammonium sulfate. It contains. So 1 and 2 are correct. Coming to 15th question. TLCl3 acts as good oxidizing agent because it is plus 3. It will change into plus 1. Means it is undergoing reduction. So it is a good oxidizing agent. Obviously statement 1 is right. Electronegativity of aluminum is 1.5. Electronegativity of thallium is more than that. Okay. So this is memory based question. It is 1.8. Aluminum, gallium, indium, thallium. This is 1.5. This is 1.6. This is 1.7. This is 1.8. The aqueous solution of AlCl3 contains Al plus 3 ions because its higher hydration enthalpy compensates higher ionization energy. Formulae of metaborate and borate ions respectively. Memory. Sodium borate, Na2B4O7, borax plus H2O in the presence of concentrated HCl, then XYMG. Okay, the product Z in the reaction is finally what you are going to use. Magnesium is reducing agent, so you are going to get there amorphous boron. Okay, this is amorphous boron. Boron preparation, you can say reduction by magnesium. H3BO3 375 heating, 435 heating, whatever the heating is, finally you are going to get B2O3. So high temperature you will be getting there B2O3. High temperature you will be getting there B2O3, and low temperature you will be getting options H2B4O7 or HBO2, all this. But here you can see at 435 Kelvin, at 375 Kelvin, 375 Kelvin HBO2, 435 Kelvin H2B4O7. This is, we need to check the temperatures better because exact temperatures we may not know. Okay, HBO2 H2B4O7 is possible. We'll check this temperatures and I will update you soon. Otherwise just Google करें एक बार. Okay ना, आप क्यों करेंगे, मैं करता हूँ. H3BO3 heating, because in NCERT only one equation is given. Heating at 375 Kelvin, H2B4O7, 375 Kelvin H2B4O7 is mentioned here. एक काम करेंगे, देखेंगे, just have patience. H3BO3 on heating 375 Kelvin HbO2 and red hot B2O3. So HbO2 is right beta, 435 Kelvin, 435 kelvins anywhere mentioned. Yeah, 435 Kelvin H2B4O7, this is mentioned. Okay, I was just checking. So we'll come back. Which of the following are correct? B and BC3 are used in control rods. Again, memory man. Correct. Boron and reaction with NaOH forms Na3BO3 and H2. Sodium borate is formed. That is also right. And boron can act as a reducing agent because it's a non-metal. All are right. Oh, good questions. The products formed when boron trichloride is reduced with lithium aluminum hydride are B2H6, AlCl3 and LiCl, right? Hot and concentrated solution of borax is treated with hydrochloric acid to give A and B. B on strong heating undergoes dehydration to give C, then C is an acetic oxide, that is nothing but B2O3. Some statements about the structure of diboron are given below. NMR and Raman spectral studies have confirmed that 4 hydrogens of diboron are of one type and remaining are of two types, right? Electron diaphragm studies have shown that diboron contains two coplanar, right? Diboron is a planar molecule. Okay, diboron will be having in one plane, that's true. But only two are in the plane. These two are above and below the plane. Boron of diboron undergoes no, only A and B. In borax bead test, which compound of the bead reacts with basical radical to form? Okay, now which compound of the bead? The compound is B2O3, boron oxide. Which of the following is a correct match? Orthoboric acid. No, orthoboric acid is H3BO3. Tetraboric acid is right. Okay, now this is orthoboric acid. This is metaboric acid. Maybe this is pyroboric acid. Maybe. Al plus 6OH minus means you are taking here hydrogen and here OH minus is less, here OH minus is more. So this is concentrated, this is dilute with concentrated borate and with dilute it is metaborate. So 27th, this is the right option. Aluminium, this is aluminium plus OH minus plus 6H2O AlOH taken 4 minus plus 3H2, the stoichiometric coefficients of A, B and C are, you can check. 2Al plus 2OH minus plus 6H2O gives us to 2AlOH4 minus. Just substitute, you will get the answer. The formula of K2SO4 Al2SO4 taken thrice 4 aluminum hydroxide. Okay, now see carefully. 4 aluminum hydroxide is called alunite. Study the following list. List 1, B2O3. B2O3 is acetic oxide. Al2O3 is amphoteric oxide. B2H6 is diboron. And this is this one. B2H6 you can call this as boron also, and we generally say diboron. You can call it as even 4312. Done. So these are there are some typical questions which are not there now in NCERT syllabus. When they are not in NCERT, you can safely avoid them. Okay, these are few old questions are always present in such kind of materials. Don't mind. If it is there in the NCERT, we are going to accept. Otherwise, no worries.